In this example, we're going to use the blood pressure.jump dataset, which is available on ELC. We could, if we look at these data, we could try to predict a patient's blood pressure using their age as a simple regression predictor or weight as a simple regression predictor. We've already talked about how that can be problematic. So instead, we're going to use both age and weight as predictors for blood pressure together in a multiple regression model. So if we go back to the notes, we see that we're going to try a multiple regression model to use the multiple predictors at once. So the first step is to fit a multiple regression, and that would be a multiple linear regression or MLR model that includes age and weight as predictors. If we go back to JUMP, to do a multiple regression model in JUMP, we're going to go to Analyze, but then we have to use Fit Model. So for simple regression, we use the fit y by x dialog, but remember that's for one y and one x. So when we have one explanatory and one response variable. In this case, we have two explanatory variables, so we have to use fit model. And in the hover over, we can see it says linear models including multiple regression. And that's what we're going to do now. So we're going to fit model, and just as before, our response variable, blood pressure, is going to go in the Y box. And we can see that the dialog box for fit model is different than the dialog box for fit Y by X. Some of the boxes or some of the options are similar. So we see Y, we see by, frequency, and weight, which we ignored before. But now we want to know about two explanatory variables, age and weight. The construct model effects box is where our explanatory variables go. And so if you remember, an effect is the change in the response when we're thinking about explanatory variables. And so we want to know about the effect that age and weight simultaneously or individually when controlling for the others have on blood pressure. And so the effects are our explanatory variables. And that's all we have to do. So we have our response in the Y box, our effects or our explanatory variables, because we want to know about the effect of these variables on the response, in the effects box, and then we hit run. The output that we get is similar to what we've seen before, but there are also differences. So I'm going to collapse all the output that we are not interested in for now. We have seen the summary of fit, the analysis of variance, and the parameter estimates table. And this is the same sort of output that we saw before in the fit y by x output. So we see here that we get an R squared, we still have the analysis of variance table, and we have parameter estimates table. And it is this last table that we are interested in right now. If you want to copy the table so that it is editable in your Word document, and this is how you would have to do it for a report, you would do copy table. But what I'm going to do is I'm going to edit. So what I did was I right-clicked on the table heading, and I'm going to copy this as a picture so that it shows up in our notes more neatly. All right, so what we have here is our parameter estimates table, the same way that we usually see them. We have our intercept. This is the slope for age, so this is B1, and this is the slope for weight. So this is B2. So our prediction equation is y hat equals a plus b1 x1 plus b2 x2. We can also think of this as bp hat equals a plus b1 times age plus b2 times weight. So if we want to plug in our values, bp hat equals negative 16 plus 0.57, or 0.58 if we round correctly, plus 0.71 times age, plus 1.03 times weight. And that's the answer to our first question. I'm going to take this and put it in our notes. So now we have a prediction equation. If one patient is 49 years old and weighs 99.8 kilograms, what do you predict their blood pressure to be? Well, we have that their age here, the person's actual age is 49, and we have their actual weight is 99.8. So we're asking what is their predicted blood pressure. So what is y hat when age is 49 and weight is 99.8? So blood pressure or the predicted blood pressure is negative 16.58 plus 0.71 times 49 plus 1.03 times 99.8. And we work this out and we get our answer. The predicted blood pressure for this person is 121.00 millimeters of mercury. So what do these coefficients mean that we found? So again, our coefficients are these sample estimates, A, B1, and B2. B1 in this case is 0.71. For each additional year, the predicted blood pressure increases or decreases. In this case, it increases by 0.71 millimeters of mercury, holding weight constant. If we were to fit a simple linear regression model with age as the only predictor, what would that slope be? Go ahead and actually do that using our data and compare the slopes. Is the coefficient exactly the same? And think about why it is or isn't. So here I'm going back to our data and I'm going to analyze fit y by x using age as our one predictor and blood pressure as our response. When we do that, and if we fit a simple linear regression model, we see that no, the slope is not exactly the same. Before, the slope was 0.71 in our multiple regression model, and now the slope for age when using age to predict blood pressure is 1.43. It has increased dramatically when we use just age. Or we can think of it as decreasing when we use weight or when we hold weight constant. So why might that be? Some possible reasons are that age and weight are associated. So when we hold weight constant, we're removing some of that variability that's associated with age and weight as well. So age is not explaining as much or is not as strong a predictor when we also hold weight constant. So I encourage you to pause this video and complete this part on your own, interpreting the slope B2 of 1.03 on your own. And then also fit a simple linear regression model and compare the slope for weight against that. As indicated, B2 is 1.03. For each additional kilogram, the predicted blood pressure increases, because it is a positive slope, by 1.03 millimeters of mercury, holding age constant. And then finally, our intercept, A, is negative 16.58. When age equals 0 and weight equals 0, the average blood pressure is negative 16.58 millimeters of mercury. Is this a correct interpretation? Yes, but we also know that this is an example of extrapolation. There is no one in our data set, if we go back and look, that has an age near 0. Our smallest age is about 46, and there is no one with a weight near 0, and in fact, there's no such thing as anyone with a mass or a weight of near 0. So this is an impossible scenario. So we have to include this intercept in order to get our best fit line, but we know that this is never going to actually happen in the real world. It is possible to have an age of 0, that would be infants, but even infants don't weigh 0 kilograms. So that is a quick review of fitting a multiple regression model in JUMP, interpreting the estimates, all the slopes and the intercept, and thinking about what that would mean in this multiple regression setting.